So in this lecture, we will discuss one or two numericals related to controllability and observability. We will see how to solve, how to check the controllability and observability of a system which is represented by a state space model. Now, let us consider one system. Let us say we have a system xt. So let us consider a system as given by these equations here. We have this is we call as the state equation, and this one is basically the output equation. Now we have to check the controllability and observability of these particular this particular system, right? Now the controllability matrix is given by PC is equal to B A B A n minus 1 into B, where n is the order of the system or number of states, right? Now in this case we have n is equal to 2 in this case, hence PC is given by BAB. Now any system is completely controllable when the rank of this matrix is n, that is PC has full rank, right? If this is the case, then we can say that the given system is completely controllable. So let us check it out. Now B is given as 1 1, so this is basically B. Here this one is A and this is C matrix, right? So B is 1 1, it is 1 1, it is already given. Now we can calculate AB. So A is 2 1 0 1, so it is 2 by 2 matrix, 2 1 0 1, and B is 1 1. So we can have the matrix multiplication of these, so we will get 1 plus 1 and 0 plus 1. Sorry, not 1 plus 1, 2 plus 1. So 2 plus 1, then it is 3 1. So AB is equal to 3 1. So from here we can say that the controllability matrix PC is given by 1 1 and 3 1. Now if the determinant of PC is not equal to 0, then PC has full rank. So let us find out the determinant here. So determinant of PC is, it will be 1 into 1 minus 1 into 3. Means we will multiply these two first, then minus these two, right? So it is 1 minus 3, so it is equal to minus 2, which is not equal to 0. Hence, rank of PC is n. So system is controllable, right? So similarly, we can also find out the uh, or we can check the whether the system is observable or not. Now these things are required to design the compensators or controllers for these systems represented by state equations or state space model. So similarly, uh, we can check whether the given system is controllable or not. Sorry, not controllable. Sorry, controllability has already been checked. So we will check the is observable or not. So to check the observability of the given system, uh, the rank of the observability matrix must be full. That is, P naught must have full rank. Or you can write it like this also: rank of P naught is equal to n, where P naught is the observability matrix, right? P naught is given by, so P naught is equal to CAN minus 1, where n is order of the system, or you can say number of states. So now let us find out whether the given system is observable or not. Uh, Now A is 2101 and C is equal to 11 in this case. Now CA is equal to uh, CA is equal to 1 1, and so it is multiplied here 2101. So it is 2 into 1 plus 1 into 0, and we have 1 into 1 plus 1 into 1. So this is the matrix multiplication. So we will get CA as a row matrix. So this is a row matrix. So CA is equal to, so it is 3, and then you have 2. Now, uh, because n is equal to 2, hence P naught is given by C and CA, right? So P naught is equal to 1 1, and then CA is equal to 3 2 3 2. Okay, so let us find out the determinant of P naught. So determinant of P naught is equal to 1 into 2. So 1 into 2, this one, these two, then minus 3 into 1. So this is equal to 2 minus 3, and this is equal to minus 1, which is not equal to 0. Hence, if the determinant of P naught is not equal to 0, then the given state space model is completely observable. Hence, in this case also, P naught is not P naught basically, sorry, uh, the given system is both, that is completely controllable and observable, right? So this is how we can determine whether the given system is controllable or not. Okay, we only have to check the determinant of the controllability matrix and the observability matrix. And if the determinant of these controllability matrix and observability matrix uh, is non-zero, so we can say that the given system is completely controllable and observable. So this is it for this video. In next video we will discuss the about some numerical on design of state feedback gain matrix using ball placement technique. Thank you so much.